It's like, so like
g of x is square root of 4 minus x squared.
Just took a huge step last week.
If they don't specify a domain, you can just assume that's true on all x. Now, truth be told, this thing doesn't exist on all x. Can you give me an example of an x value you could plug in here that wouldn't give you a y value? 2 would be like right on the cusp. If you plugged in 2, you'd get 2 squared is 4. 4 minus 4 is 0. Square root of 0 exists, but just barely. So plug in 3. 4 minus 9 would give you negative 5. Square root of that ain't happening with the real numbers.
Imaginary.
So your domain less than or equal to 2, but there's also a left side cutoff, isn't there? Because could you plug in negative 3 here? Well, negative 3 would give you 9. Again, 4 minus 9.
That's not happening.
So what's the left cutoff? Negative 2 is the left cutoff. So domain is actually negative 2 to positive 2, including the endpoints. You can include 2 and negative 2. You can do square root of 0. That's totally, as the kids are saying these days, legit. But anything beyond that, anything negative, you can't have a square root of.
last year.
So we have some endpoints after all, don't we? These are going to be our endpoints. We also need to find out when g prime is 0 and when g prime is undefined. So I suppose we would probably figure out what g prime is, just in general. I don't like the square root as much as I like thinking of that as power 1/2. So this is a quantity to the 1/2 power. If I'm going to differentiate it, what do I do first?
Bring down the 1/4.
Your 1/2 comes down front.
And then right side.
Don't screw with the quantity.
Negative 1/2.
Right. Power drops from 1/2 down to negative 1/2.
Times.
Chain around.
Good.
2x.
Chain on the derivative of the inside.
Negative.
Term by term, that's 0 minus 2x. So negative 2x. If you want to clean this up a little,
Negative 2x.
What did you do?
with this 2 and this half, they're gone, right?
It should be negative x.
Negative x would be the top.
Whatever.
There's the denominator.
There we go. Wow. That was quite a tough one.
So it's easy to tell when g prime is 0. Yeah, if you have a fraction and you're setting it equal to 0, really just the numerator has to be 0. If the numerator is 0, the whole thing's going to be 0. Unless it's 0 over 0. Yeah. But you don't. If you plug 0 at the bottom, you get something. So x equals 0 gives us a g prime value of 0. Yeah, when g prime's undefined, it starts being undefined at the endpoints, just like the original function started being undefined at the endpoints. So don't worry about anything beyond these. So let's just kind of focus on endpoints again. G prime is 0 when x is 0, because this is g prime. So if this is 0, if the top is 0, whole thing is 0. Alright, so endpoints are negative 2 and 2, really. That's where the function starts and stops being defined. So those are x values to check as well. So these 3 numbers make up our team of critical numbers. What do we do with them?
Plug them in.
Plug them in.
Top one.
Plug them into G.
Zero
Now would be disrespectful.
So let's test -2 in the original function. You get square root of 0. You do square root of 0.
0. 0 times 0 equals 0.
Plus or minus.
Darn tootin', said the cowboy who had eaten too many beans. What about G of 0?
Douche.
Plug in 0, you get square root of 4. The positive range only, we'll play by just the positive range here. That's going to give you 2. And G of positive 2, square root of 0, gives you 0. So really these are absolute, we got an absolute min value of what?
0.
0. That's as low as it goes. And we've got an absolute max.
Dose.
Yep. The y value of 2 is our highest y value. Yeah.
How would you know when to find the relative min max?
Relative mins are going to show up more if you have it graphed or if they give you the graph. Generally, when they give you the functions, I think they're going to more or less just ask for absolutes. Could be a mistake. Good thought. All right. So we got our next assignment. What are we? 21.
Yeah.